All right, so you should have gotten a message that lets you know that this is being recorded. So note solving absolute value inequalities is where we're at now. And we're going to go through and talk about that. So when we're solving inequalities, there's a couple things we got to remember. One, when you're looking at a less than situation, so I have an inequality here. This is a less than. When it's less than, what happens is that you're going to create a compound solution. Okay, when it's less than, you're going to end up with a compound solution, and it could be written as one whole statement right here, or it could be written in two parts. Okay, the numbers both may be positive. It's not guaranteed that one is negative and one is, this should be a little negative right there. And so when you are writing it, it just becomes one solution. Our greater than situations, and this also, I'm sorry, applies to less than and less than or equal to. So it could be, as you can see in the parentheses, same thing. It's the distance from x to 0 is greater than that value. And so if it's greater than that value, you end up with a disjoint solution / split solution. So we're going to analyze both types of situations and go from there. I missed where it go. Good morning, Emily. Okay, so we're gonna keep going. I'm trying to make sure I put everything that I wanted to. Oh, so what happens here, remember that these represent open circles. These represent closed circles. This represents an open circle situation. This represents a closed circle situation. Pay attention to the words and. So if in the problem it says and, that lets you know you have a compound solution. And the problem, if it says or, that lets you know that you have a disjoint, a split solution. Okay. Compound solutions are also called joint solutions. All right, so solving an absolute value inequality, how do we do it? The first thing you want to do is isolate the inequality, and then you're going to set up your two equations. If you're working with the less than situation, so I'm working with less than, are the numbers, the C are the numbers that satisfies negative C in between, negative C is less than the X, less than the positive C. And just remember, less than is an and situation. So what's going to happen is that our graphs are going to visually overlap. That's why they are compound, okay? Next, the solutions when we have a greater than. C are the numbers that satisfies X is less than negative C or X is greater than C. So remember, great or graph goes on opposite directions, and then you solve the inequalities and graph the solutions. So that's what we're going to be doing this morning. So the first problem we have is absolute value of 2x minus 1 is less than 5. So because it's a less than, that lets us know that we're going to have a compound solution. So we're looking for where they're going to overlap, a joint situation. And so you either can solve it as a compound or you can split it into two different equations. I personally like solving it as a compound. It helps me kind of just stay in that order. So I'm going to show you, I'm going to model solving it as a compound. So solving it as a compound would look like this. You're going to have your negative 5. So we have negative 5 is less than 2x minus 1, which is less than positive 5. And so we're going to solve this simultaneously. So technically this would be one equation and this would be the other equation. So you would have one equation where -5 is less than 2x minus 1, and you would have another equation where 2x minus 1 is less than 5. So if you want to write it as separate equations, by all means, feel free to do so. But I think you would like seeing it as compound. So I'm going to add 1, because I got to isolate the variable, add 1. Sorry, step 2 is to solve. So once I set up my compound, I'm going to solve. And that gives me -4 is less than 2x, which is less than 6. I'm going to divide by 2, divide by 2, divide by 2. That gives me -2 is less than x, less than 4. That's not 4, that's 3, Sean. It's early in the morning, y'all. Here we go. Less than 3. And that would be our solution. Again, it's 2 separate equations, but I solve them as one compound solution. So then I'm going to create the graph. So on the graph, I know that I'm between -2 and +3. I'm going to put 0 in here somewhere. Have a little accuracy. At -2, it's strictly less than. At +3, it's strictly less than. So I'm going to have open circles and connect the lines. So this would be my numerical representation, and this would be my graphical representation of my solution. How do you feel about solving a compound? Is there anyone that would want to see it solved separately, or you feel comfortable working both sides of the inequality? Okay, I'm going to take your silence as we're good to. Wait. We're going to move on. Yes.
Oh, okay. So, you know how on the solution or the equation up here, it has a 5. So we grab the 5 and we make it into a negative, and that's how come you
Yes.
have a +5 and a -5.
Yes, just like when we solved the
Okay.
equals. So remember when we had the equations and we would set the equation equal to the positive constant and to the negative constant?
Yeah.
It's the same thing here, except now we're using the inequality symbols.
Oh, okay. Thank you.
You're so welcome. And so again, if seeing it as a compound isn't your thing, you can work it as 2 separate problems. If you choose to work it as 2 separate problems, your first problem would be 2x minus 1 is less than 5. And your second problem would be, because you're going to multiply by -5, anytime you multiply with an inequality, it's going to change the sign, right? And so then it would become -5 is less than 2x minus 1. And you can work them separately if you feel the need to. But that's what this would be, split into 2 separate equations. All right, next. So here I would like for you to attempt. So I can give you about a minute to try and find the solution here. So I'll pause and give you a moment. Okay, so for this problem, again, it's a less than situation. Even though it says less than or equal to, it still means that I'm doing the same. Uh-oh. All right, so it's a less than or equal to, which means that I'm going to have a compound. Okay, so step 1 is to create my compound. My absolute value is by itself already, so it just means it's going to be -8 less than 3x minus 4 less than or equal to +8. And then step 2 is for me to solve my compound. So step 2 is I'm going to solve. So to solve, my job is to get x by itself. So you should have added 4 to both sides. And that's going to leave you with -4 less than or equal to 3x less than or equal to 12. Then you should have divided by 3. And we're left with -4/3 less than or equal to x less than or equal to 4. Notice how I left the -4/3 as a fraction. You will do the same. Fractions are our friends. And then I'm going to graph the solution. So graphing the solution. So I'm going to put 0 somewhere. -4/3 is going to be a little bit more than 1. Here's my -1. And so I'm going to put -4/3 right here. And it's a closed circle because it's equal to. And then I'm going to graph 4 on the other side. It's a closed circle because it's equal to. And then I'm just going to connect them to represent my compound. How do we do? Feeling okay?
All right, I guess.
All right, I guess. I'll take all right, I guess. All right. So next, we're going to move into our greater than situation. Okay. Greater than is where we're splitting. So for greater than, we're going to have to split because it's telling us it could be this or. Okay. That situation of that or is what's going to get us. So 1, we're going to split and flip is what I call it. Split and flip. Okay, so for splitting and flipping, I'm going to take this. I'm going to have 2x plus 4 is greater than or equal to 6. And then when I split and flip, I'm going to flip the sign and I'm going to flip from positive to negative. And so I'm going to be working with 2x plus 4 is less than or equal to -6. Okay, the reason why this happens is because we multiplied by a negative. And when you're working with the inequality, anytime you multiply or divide by a negative, what's going to happen? That flip, you're going to flip the inequality symbol. All right, then step 2 is to solve. So we split and flip, and then we just solve. So I'm going to subtract 4. That gives me 2x is greater than or equal to 2. Divide 2. And that gives me x is greater than or equal to 1. Repeat the same process. Subtract 4. I get 2x is less than or equal to -10. Divide by 2. And I get x is less than or equal to -5. So my 2 solutions, it's an or statement. It can be x is greater than or equal to 1 or x is less than or equal to -5. It creates an or situation. And then graphically, when I graph this, it's going to be disjointed, right? It's going to be 2 lines that are not friends, not touching each other. So it's going to be disjointed. There's my line. And I'm going to find 0. I'm going to put 0 here. Put -5 here. Put +1 here. And it's closed circles because it's equal to. And it says x is less than or equal to -5. Or x is greater than or equal to +1. And that will be my disjointed graph. Any questions about working with greater than? Seems doable?
Yes.
Okay, cool, because your turn to do.
But then you changed the question.
Oh, you had a question?
No, I said I was going to say no, but then you changed the question, so.
Oh, it's your turn to practice since you don't have any questions. All right,
None.
So here we go. Again, notice how I have a greater than symbol. So that lets me know that I'm going to have a disjoint / split situation, right? So step 1 I'm going to split and flip. I'm going to split and flip. So I end up with 5x plus 10 is greater than 15, or 5x plus 10 is less than negative 15. So I split and I flip. Step 2 is for me to solve. So step 2, I'm going to solve for x. So I'm going to subtract 10, and I get 5x is greater than 5, divide 5. And we get x is greater than 1. I'm going to repeat the same process, subtract 10. I get 5x is greater than negative 25, divide 5. And we get x is greater than negative 5. And so then third thing is to graph. So third and final, I'm going to create my graph. It's a disjoint graph. So I'm going to find 0 again. I'm going to put 0 here. Put negative 5 over here. 1 over here. And this time they're open circles because it's strictly greater than. And bam. How do we do? Feeling all right? You can always use the little thumbs up feature on your situation.
I did surprisingly good considering that I wasn't here for this part of the notes.
Perfect. There you go. I opened a window. My bad. I was trying to find the little thing that shows you what the thumbs up and all those things you can do, but I clicked a bunch of things. Here we go. So last, our special cases. Dun, 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 dun. Negatives. Okay. Here are our special cases. If it's less than, so if I have this absolute value, it's isolated by itself, and it says less than or equal to negative 12. Remember that absolute values are your distances, which cannot be negative, okay? And you can choose any value for x, and the left side of the inequality will always be positive, okay? Positive numbers are never less than negative numbers. So therefore, in this situation, the final answer is no solution. Does that make sense? Because no matter what number I plug in, this will never be a true statement because I will always produce a positive number. So it'd be a no solution. Okay. The other special case, greater than. If I have greater than symbols and a negative constant, absolute values are distance and cannot be negative. True. You can choose any value of x, and the left side of the inequality will always be positive because it'll always be positive. Positive numbers are always greater than negative numbers, okay? So the solution here is infinite solution. So you would have infinite solutions. And those are two special cases. So if you are less than a negative, that's no solution. If you're greater than a negative as an absolute value, then it's infinite solutions.